host.
Good morning. We're going to be talking about agentic enrichment today, which is the concept of allowing agents to be able to retrieve data to solve for any sort of problems and prompts. I think this concept hasn't really had a name before. It hasn't really, I think people kind of do it, but they do it in quite ad hoc ways. So today my goal is to kind of make it real. So, oh, and then a few other just kind of operational things. This is recorded. We will send it after. If you have any questions during this webinar, you can throw your questions in the Q&A on Zoom. If you're on LinkedIn, you can leave a comment and we will respond there as well. Yeah, and then some of the links that we will be sharing, we will also send in a follow-up email. For example, the repository, some of the data examples, all that will be included in the slides as well. So today, I want to talk about agentic enrichment. I want to first start by actually talking about how things are changing and kind of what agents are. We've started most LLM products that are built around the concept of a query. The idea of a query is that it's a one-shot thing. So for example, you ask a question to a chatbot, an LLM, and it has one chance to respond. The idea of agents is putting that in a loop. So it can think through by itself. It can try more things. It could potentially use a ton of different tools to accomplish any sort of problem at hand. And as this happens, the complexity of what you can build goes up, and the type of data you need and the way you need to retrieve it changes dramatically. If you've been in the agent space for any period of time or built anything of LLMs, you've probably heard or have built with RAG. The idea of RAG is this. You take a set of public documents or any documents, you embed them, which really just means you're indexing them for search. When the user asks a question or has a query, you go and retrieve relevant context to be able to give to the LLM to answer the question at hand. So the way it works is you're asking a question or the user asks a question, you retrieve relevant information, you put it in the context, and you do an output. So the thing here is it works pretty well. Like RAG obviously works really well, but it has limitations. There are many, many situations where RAG doesn't work very well. I'll give you an example. Let's say we were building RAG for like Amazon.com or DoorDash or something. We would first, going back to this, need to find a set of documents to index so that we can help answer questions. Almost always, those documents are going to be like our docs, our help center, a set of data and text documents that we have that are just kind of generic answers to things. And we attach that to the LLM via RAG. So when someone asks, why is my DoorDash taking forever? I've been waiting for like an hour. Going back here one last time, the query from the user is, why is my DoorDash taking forever? It's going to go into the vector store and it's going to find relevant documents to that question. Those relevant documents are going to say things like here, common reasons why a dash might be delayed. That will be injected into the context, the prompt, and that prompt will be sent to the LLM to make an output. So what that will look like here is, hey, I'm really sorry that your order is delayed. Here are common reasons for delays. You could imagine that this is actually pretty awful UX. Like if you as a person were asking this question and this was the answer you received rather, you would probably not be very happy. This is kind of the best you can do with RAG. The problem is that the data you actually need to answer this question is data about the orders, data about the dasher, the restaurant. There's all this other information, but you can't currently give agents or LLMs access to that private information. It's in structured form, so it's not like you can use a vector DB. Two, it's kind of can be a security nightmare. The nice thing about RAG is you typically do it on documents where every document is publicly accessible. Well, here that's no longer the case. You want it to be really scoped to the minimum scope. With RAG, we can just do a search, like a search engine search, pretty much. So this sort of data, that doesn't really work. We need a different way to be able to find and retrieve relevant data. What we'd like to happen is for the agent to be able to find semantically relevant information across all of your APIs and databases, retrieve them in real time, and see only the minimally scoped access that it needs to be able to answer that question. This is kind of what we need to make agents work. This concept is called agentic enrichment. Agentic enrichment, unlike RAG, where RAG is kind of a thing that you always call on every single query, with agentic enrichment, you typically do in a loop. So the agent actually has all these things show up as tools for the agent. And so the agent will have a set of tools to be able to retrieve relevant information and answer the question. So a tool might be, for example, get user order info, get dasher info, and it would be able to use those tools to retrieve that data and then answer the question at hand. The thing here is the tools have to have really good documentation so that the agent knows what they are and how to use them. The implementation of those tools need to be production grade, and then security has to be fit into every single aspect of that step. So the big difference, I guess, is RAG is almost like a tool that you always call. Here, it's agentic, so the agent can decide when it needs to retrieve data. With RAG, there's typically one data pool, right? It's like all of your help center. Here, you might have lots of different types of data in lots of different formats, and you might need to be able to kind of go through different things. Like, for example, get user info, get dash info. And so that you need an agent to be able to loop through this and question through it. Okay, so someone asked a really good question. RAG versus agentic query. Uh, it's kind of a bit of a pushback. It's saying, hey, can't we do what you're saying with RAG as long as you include the order status in the database? The issue here is that RAG inherently works a little differently. Like the way RAG works is going back to maybe this query, you embed the query. Using the query embedding, you find relevant documents. So here, when someone asks, why is my DoorDash taking forever? I've been waiting for like an hour. You're going to embed this query and do a nearest neighbor lookup for paragraphs essentially similar to this thing. That's not going to find you the dash info. That's going to find you like what would the paragraph in the vector DB even be in that situation? What you'll find is as you go down that rabbit hole, you'll kind of come to the same conclusion of you need a special tool to call to get the information. One thing I've seen done, which isn't really RAG, but kind of solves it, is you will grab all the user info, all the order info, all the information you have, and just immediately dump it into context every single time. That's kind of agentic enrichment without the agent part. You're just kind of grabbing all the structured data and feeding it into the prompt. But definitely like traditional RAG where you use a vector DB does not solve that question because the way traditional RAG works is it's a nearest neighbor lookup. Here's some text that the user asked, find me relevant paragraphs. You're never going to find here's a specific order. And imagine that, right? Because you would have all the orders in the vector DB. If you did the nearest neighbor lookup, you might get other people's orders too. So the scoping becomes a big issue as well. So it's structured data. You would typically put it in a structured DB, whether it be Redis or Postgres. And to access that, you need to use something like a tool rather than nearest neighbor lookup or search. Good question. A really good question, actually. Awesome. And yeah, keep throwing questions down as they come up. So we come to this, I guess, whoever the idea here is that we need tools to be able to access data, like order info, dasher info, etc. The issue is, or not so much issue. There's ways to do that. We can build all these tools ourselves and kind of try to, and this is what I've seen a lot of people do. They'll build agents. They'll build, I think the generic tool that you learn how to build when you're building an agent is like get weather info. That is actually like a form of agentic enrichment, where now the agent has access to be able to get data like the weather, to be able to answer a question. So if someone asked a question and the weather was relevant according to the agent, it could go retrieve that data. So the way things have been done historically is that the tools are built into the agent. So every single agent builder will build these custom tools. As of recent, there's this new concept, which I imagine a lot of you have heard of. It's kind of been quite hyped up, is this idea of MCP. What MCP is, at its core, is rather than the client or the agent having all the tools hard-coded into it, you can point the agent at a server, and that server will have the tools. So if you want to interact with Slack or Gmail, today what you would do, or not today, maybe like 6 months ago, what you would do is you would build all these tools to interact with Gmail and Slack. Now you can just point your agent at the MCP server for Slack. When you do that, you now have access to their MCP and tool implementations, which are likely going to be much better, much more supported, much more powerful than whatever you kind of build yourself locally. So the concept of MCP, there's a lot of points of MCP, but I think the thing that is most important to take away is that there's nothing special about MCP other than it's a standard. And all of the builders from, Anthropic, which originally came up with it, to OpenAI, to Google, everyone now supports MCP. So now, as a builder, a service builder, like if I'm building Gmail, I can just release an MCP API. I can let people point at it, and now they can interact with my application. So, yeah, it's a pretty interesting shift, and it changes the architecture of how we build things. Going back to this idea of agentic enrichment, we could build each agent having all these specialized tools, or as an organization, I can build this agentic enrichment layer, which has all these tools. I can change those tools. I can create all this logic, but I'm building an API the same way I've built REST APIs, and I'm pointing the agent at the API. The difference between a REST API and MCP API is that an MCP API has some discoverability aspect to it. It's a little different, like there's different concepts with it. But I think the biggest takeaway is you can't point an agent at a REST API and say, hey, go use it. And it might be able to figure it out, but it won't work very well. MCP is native. So if you point at the MCP API, it knows exactly what to do, exactly how to understand all of the parameters and how to work. So the idea, why this enables agentic enrichment is that now, as a builder, I can build an MCP server. That's like my data API, the same way I would build a typical REST API. And I can now point my agent at it. So this architecture, I think, is much better. Why I think MCP is really important, and maybe where I think things are going, and why concepts like agentic enrichment are so powerful. I imagine a lot of you use Jira or Asana or whatever, similar project management tools. And I would bet that you don't really love using Jira very much, because most people don't. The problem with a lot of these applications is that the UI is based around point and click. If you want to create a new task in Jira, you have to hit the plus button, you go through this long form, you hit enter. Every time something changes, you have to go find that stuff again and edit it manually. It feels very, very like it feels like you're editing a database by hand. It's really painful. With MCP and the ability to connect MCP to Jira, I don't have to do that anymore. I can just tell Claude or whatever, here's what I'm trying to do, or I can dump a transcript. I can take this webinar and say, hey, there's a lot of information here. I want to learn more about agentic enrichment. Can you create a little project plan for me in Asana? And it will go do it. So the way we interact with the web has fundamentally changed. We used to, and to this day, most of us still kind of do interactive things by going to a website and kind of clicking through. Within the next couple of years, we will interact with all of our applications via agents, whether that be a proprietary agent or just through ChatGPT. That is the new way to interact with the world. And so agents are becoming a more and more critical piece of the puzzle. Then the question is, where does Jira fit into this new world? And the answer is that it becomes like a system of record. So what all these APIs become are GET requests and POST requests, really. So GET requests are essentially agentic enrichment, the ability to retrieve and understand data from all of these applications to be able to help and understand and answer questions. So if I ask, hey, what's my day look like today? It can go grab my calendar and summarize. And then POST, which are tools. So the ability to create a task in Jira, write a message on Slack, draft an email. That's the new interaction paradigm. We interact via Claude, everything gets done over MCP. And so agents are becoming more and more critical to any organization trying to build thinking forward in the next couple years. So I've talked about this kind of broadly. There's this idea where I can retrieve semantically relevant information. I can, excuse me. So I can retrieve semantically relevant information and grab it. Now let's talk about how that actually looks and works under the hood. Yeah, so someone asked, how does MCP enable autonomous AI agents to dynamically discover and invoke external tools without hard-coded interfaces? So that's a really good question. The way it works is MCP, with MCP, when you write an MCP server, like I'll show you an example here. So this is using Enrich MCP, which I'll talk about. But I create these become tools. All these tools, when I point the agent at it, it sees the tool and it sees the PyDoc and it is able to learn how to call this tool. And so the way it works is that I just point at the server. The server has a special API call, which pretty much calls get all tools. It will return all the tools, all of our descriptions, all of our parameters, and their return types. So that's how it works. Yeah. So anyway, that's kind of the basis of how MCP works. Now the question becomes, okay, if I'm using fast MCP, so let me actually just show you how fast MCP looks. So if I go here, I'm going to show you how a typical MCP server looks. You will use fast MCP, you create a tool, and you might create a resource like a get greeting. So yeah, this is generally how you build. This becomes an MCP server, and then you can allow Claude to interact with it and do things. So you can say, add 10 plus 12, or this is like a made up example, but you can imagine with Gmail, each of these tools would have like, get emails, get unread emails, whatever, all those different tools and resources, and it would work this way. So the issue, right, when you're doing enrichment is there's this semantic information, right? Like you need to understand, okay, we have a user in DoorDash. Here's what a user is. Here are its attributes. They have orders, they have a name, they have a zip, they have a location, all that stuff. And a user has orders. So you need a link between user and orders. You need a link between order and items. You need to kind of explain to the agent how you're essentially explaining your business model, your data model to the agent so it can understand what data it has access to and what that data means. We call this a semantic engine. You need to then provide this to the agent in a way that is useful. So one way to do this manually is you would write get user info, get user location, get user orders, get order, and you would like write all these separate tools yourself and kind of try to explain via the tool descriptions how they relate to each other, which I've seen a lot of people do. The implementation of those tools will be serving. So that includes like low latency serving or something similar to be able to handle those sorts of questions. And then you have a governance layer, right? Because, for example, if I ask, why is my order taking forever? You need to make sure that I can only see, as the agent, I'm acting on behalf of Marie, let's say. So I should only be able to see Marie's order and like Marie's information. I shouldn't be able to jump between Marie's order and my order. So you need all these things to work together with an MCP endpoint. This is how you build agentic enrichment. You need to have a semantic graph explaining how all of your data attributes and models work together. You need to, on top of the semantic graph, provide governance to explain how it can go and flow through those semantic data. And then you need a serving layer because in the end, this data is stored somewhere, whether it be behind the API, whether it be on Mongo, and you need to be able to do low latency serving on that thing. So again, if you were to build this from scratch, you would build an MCP tool. Probably there'd be, for this example here, where you have users and orders and locations and names, etc. You might have like a dozen different tools. You have to have and explain how these tools work together, and it becomes a very painful and manual process. As of today, we have open source enrich MCP, which I was just showing you. You can find it at Featureform, github.com/featureform/enrichmcp. If you look at it, I'll show you how to build agentic enrichment, and I'll give you a little demo of how it works. So in this example, we create an enrich MCP app. We give it the title, which explains what it does. We give it a description. We then define our data models. We say we have users. Users have ID, username, email, all this information. And we define relationships, which are a relationship to another entity. So a user has a list of orders. And here's a description explaining what that relationship is. I'm going to take a second and answer some Q&A stuff actually real quick. Okay. Could the MCP run on Ollama local custom AI? Yes. I believe Ollama supports MCP. I actually don't know if that's true, but I think it does. If it doesn't, I'm sure there's some like library that someone's built to build the integration scheme. Is the governance layer standalone service that wraps around MCP endpoint, or is it embedded within MCP server itself? So it's a good question. It has to be both. Based on how MCP works, the authorization logic might be in a different server, but that server has to be like I can't do off on the client side if that makes sense, because you can't trust your client. So you have to do it on the server side. Now you might offload the actual logic of how to do the governance to something else, but the endpoint has to be the same, if that makes sense. So the entry point has to be one endpoint, and then the governance has to happen within the endpoint. Whether that be in the same Python function doesn't really matter. You can like call some other service to say, hey, is this authorized? Which is what you would typically do on an enterprise. Or you could just embed it. It's kind of up to you. There's not really the right way, but it has to be on the server side. Are we still embedding the query in the real-time database? We're not. So in this world, there's no embeddings. There doesn't have to be anyway. What you're doing instead is you're telling the agent, here's a list of 50 tools or 100, let's say, resources that you have access to. Here's how they work and combine together. Whenever you need one, just know that you have it and you can call it. So it's this different concept. The thing is with RAG, you only have one shot. So with one shot, you just go and grab relevant information or data you think, text you think is relevant, and you just give it to the prompt. That may or may not do better. For this agent, you have a loop. So maybe in the first loop, it doesn't need any tools. Then on the second loop, it realizes it needs information. On the third loop, it realizes it needs other information. So in that way, structured data, you can almost think of it's not exactly true, but you can almost think of RAG is for unstructured data that's public. Agentic enrichment is for structured data that is typically private and proprietary. And so that's where you need to do it. It's a little different of a use case. Okay, so wouldn't it be better off to give access to all orders instead of a specific single order so that it can potentially generate insights based on all the orders and provide potentially enriched responses as appropriate? So the answer is yes. That's a really good question. But you have to be careful, right? Like you might give an endpoint, which is something like let's say that this happened in San Francisco. Maybe you have an MCP endpoint or a resource, which is get average delay of dasher time in San Francisco. And you can generate that based on some information. You just have to be careful because you don't want to accidentally give access to all orders. You can't trust the agent to hide anything. So for example, if Marie asks a question and the agent is able to get my orders and her orders, and in my prompt I say don't show anyone else's data, you can't trust that because I can write some prompt to get around it. So you have to build security by design, which means you need to scope everything or anonymize all the data that goes into the agent. Otherwise, it's a security nightmare. This is why things like Enrich MCP, why we built this library, is partly to make it harder to do things wrong. Um, cool. So someone asks, this is very technical. How can accountants and other professionals work with MCP and agentic enrichment to gain insight for decision making? That's a really good question. I know this is a more, let's call it technical thing. It's about building more. But in this demo I'm going to show, I'll show you generically how to use MCP, which I think might be interesting and useful. Okay, I got through the questions. Let me go back to presenting this library. So just to recontextualize, we've created an application. It's Enrich MCP. We create our Pydantic model. It's an enrichment. This is a Pydantic model under the hood. We define our fields. We define our relationships. So we know that a user has a list of orders. And you see it, I call that a relationship. We have products. Products have price, stock is active, etc. We also can have like kind of complex fields like fraud risk, which is maybe built by some other model. We have orders, which can have status, created, risk scores, first order, all this information. You also can see the user who placed this order, which is not a list, it's a single user, and the list of products in the order, because obviously an order would be made up of multiple products. So this is our data model. All of these descriptions are required. The agent needs to understand. It can't just get a field called fraud risk or risk score. It doesn't know what that means. You need to explain to it what all these fields mean, what a user is, what a product is. In the description of the application, you need to explain, okay, here's what this whole model means together. Then you can start generating, we just generate a lot of fake data, just for this example. Then we create these resolvers. So this explains how do I get users' orders by user ID. So I grab the user's orders, I find the orders that they've made. Order.user. As you can see, I'm creating all these resolvers. These resolvers are just explaining like call it the concrete details. This is defining the semantic layer. Like, oh, I have orders and users, etc. The resolvers explain how do I take that and then turn that into actual data that I return to the user. I also specify these top level resources like list orders, list products, list users, get user that I can use as well. So this is obviously a very like simple derived example. I can run this and connect Claude to it, which I'll show you right now. And then I can ask questions and start using it. So I'm going to share a different screen with my Claude just to show you what that looks like. And then someone asked a question of like, hey, I'm non-technical. How do I use this stuff? This will also answer that question as well. Okay. So this is Claude, which is like ChatGPT. If you haven't used Claude, you can just download it on your desktop. It's by a company called Anthropic. If you go here, you see these different tools. You can connect your Google Drive, your Gmail, your calendar just by clicking these buttons. You can connect Asana, you can connect a lot of things. I actually connect my local file system, and you can see the tools that it has access to, list directory, create directory, etc. So it is able to access all of these tools on my file system. This here, this is the thing I just showed you. This is the enriched MCP. So let's say I ask, you are a service agent bot, help me find suspicious transactions. This is a live demo. We'll see what it does. So the first thing it does is it explores the data model. This is a special API that we create. What the data model does is it describes what we have users and products and orders and how those things are related to each other. Then you can see it's listing orders. It's starting to get information. First, it listed the order and it put a flag, like which ones are flagged. So it's able to give parameters. It's looking for users. It's deciding to run some JavaScript code for some reason. But you can see that it's looping through this stuff and it's actually going through our data model that I showed you to be able to answer the question at hand. It's even writing code right now based on the data it retrieved to try to answer the question. So I'm actually really curious what it's going to do. This is actually very different from what I've seen it do before. So, okay, this whole thing is a loop, right? I didn't do anything. All I did was I gave it to Enrich MCP, and look what it's doing now. It is explaining what's happened. It's explaining what it found. It went through our data model by itself. It was able to understand what the data was and answer the question at hand. So that's pretty cool. At least I think it's really, really cool. So this is how agentic enrichment works and how it looks. Okay, so if you have any questions, it's a good time to ask questions. So I'm going to go through them real quick. Does the MCP spec recommend any practices for audit logging and usage tracking, especially when AI tools invoke external APIs? The spec does not provide any recommendations on how to do it. So it's kind of on you to do it. And yeah, unfortunately, it's kind of on you to do it. But in Rich MCP, we're adding a lot of stuff around audit logs and usage tracking. That's kind of a big piece of what we do. When connecting via cloud desktop, how does auth and scoping work? Good question. So the way that works, I'll show you actually right now. Like for example, when okay, there's one question, which is how does auth and scoping work? So auth and scoping, there's two parts to it, right? There's auth-in and auth-c. Auth-in is just proving your identity. It's like logging in. Auth-c is like, okay, I'm Simba, the user. What can I do? The auth-z part has to be built into the MCP endpoint. The auth-n part can be set up another way. Can you explain how to connect MCP to auth? So in this case, I'm running MCP. I'll actually show you what I did. Um, so you can add, like for example, here if I want to add Gmail, I could connect Gmail. If I wanted to add more MCP servers, I don't know if you can see this based on how I'm sharing my screen, but at the top you hit settings, and then there's a developer thing, and then you add them there. If you go to the MCP docs, it shows how to install MCP servers. Can you explain the goal of this example? So the goal of this example is going back to maybe the examples we gave before about the DoorDash. I need my bot, my agent, to be able to access data, live user data, to be able to answer certain questions. The problem is, how do I do that in a way that works and is safe? Here I'm showing you that I built that MCP server. I showed my data model of users and items and orders. I defined all that stuff. I connected my agent to that server. And now the agent is able to access that data model, list users, list orders, go through all of this information to be able to answer any question at hand. That's kind of what this is showing. So to summarize, here I'm gonna share my screen one last time. Oh, I think one more question came in. Is this for the paid cloud version? I don't know if the free version supports MCP. I think it does, but I don't know. I'm not sure. Um, okay, I'll answer. How did it perform an analysis component to come up with these suspicious customers? So that's a great question. It decided, so all I gave it was the data, right? It was able to think through that data. So it's not like we gave it some special, like it is smart enough in theory to answer a lot of questions if it has the right data. For example, if I give it some code, like imagine when you use ChatGPT and you're writing code, I imagine a lot of the time you're copy and pasting your code into like ChatGPT to answer the question, right? Or if you wanted to respond to an email, you copy and paste the email and you put in ChatGPT. What you'd like to happen is that it can go and find the information itself. But to do that, you need to, one, give it a way to do so and find the relevant information and answer the question at hand. Um, so that's what I'm doing here. I'm just giving it access to the data. It is then itself, based on that data, thinking through it and coming up with an answer, right? So maybe like going here again, like the agent is just inherently smart, I guess. You can think of it that way. It can think through the data. It just needs the data. And so what agentic enrichment is allowing an agent to retrieve data it needs to answer any question. Cool. So where did so one second. Okay, there it is. Um, on the cloud screen, how was it able to recognize the MCP that you were referring to while prompting for queries? Um, so I connected it before. Um, so I didn't really show you how to connect an MCP server to Claude. If you Google it, it comes up. It's actually it's you just write like a line of code in a JSON thing, or if it's pre-built, you can just hit integrate and it just works. So I connected it before because I had it running just for that demo. Once it's connected, it is then able to go into that server and retrieve relevant information. Um, so maybe just showing the code again, just to go back into like what happened. What the code did was provide like we have users and products and orders, right? I don't necessarily say, hey, I don't have an endpoint, a tool that's like get fraudulent orders. What I do have is get list users, list products, list orders, right? So I gave this to the agent. The agent was able to list all that information, loop through all this data I gave it, and based on that, decide itself what it thought was a fraudulent order. I did not, again, it's not like it is no like, list fraud orders endpoint. It is by itself doing that. That's the thing that's really powerful. But I'm just giving it access to the data itself so that it can answer the question. If we go back to that example of like DoorDash, when someone asks, why is my DoorDash taking forever? Rather than using RAG, where we just get random paragraphs from the help center, I'm now able to actually have it go and find live orders, live items, live products, and answer the question. Awesome. This is open source. Enrich MCP is. If you want to do us a favor, you can go to github.com/featureform/enrichmcp and just give it a star. Up here, I'll give it the first star. We just literally open sourced this morning, this week for this specific thing. We're going to be doing a much larger launch very soon, but you're able to use this today. It's ready to go. There's a quick start if you want to like understand how to use it and what to do. And yeah, it's really powerful. I really recommend taking a look at it. Oh, one more question came in. Do you have any insight on how this can be used in the EU, given the data security laws and AI Act? All the best from Vienna. So, uh, I it's a good question. Like, this is like data privacy. I almost like don't want to answer this question just because I don't want to misspeak. So I mean, you can do RAG in the EU, obviously. So this is still kind of relevant to that information. Like you're still able to do that. I think lots of the stuff around data security laws are much more about what you can delete, what you can show. I'm gonna just hand wave ask a lawyer. I don't really want to like misspeak for that question, especially on record. So sorry. But thanks for joining in from Europe. What does the decorator app.resource do? Yeah, so app resource is like a top level thing. So this is saying, hey, list customers is a top level resource that you can go and use. There's get customers, get customer by order. These are resolvers. Resolvers are saying, hey, within the order, there's these relationships. Here's how you can go down that node. Again, if you think of it like a graph, right? Like this. The resources show you how to get these items and orders, and then the resolvers show you how to go down these like edges to get to other places and like sub places of it. Someone asked, can you place the GitHub in chat? I will gladly do that. We'll also send it over I'll put it in chat, but also it will be included in the email afterwards. So I just put it in chat. If you want, you can take a look at that repo, give it a star. Let us know what you think. But yeah, you can start using this today, and hopefully it allows you to build some really interesting, powerful applications. Okay. I'll leave just another minute or two. Maybe Marie, you could kind of talk about what happens next. And if anyone has any questions, you can throw them in the Q&A. Oh, one more just came up. What are the best MCP servers that can be used to develop applications? So if you look up MCP servers, there's a repo of a lot of MCP servers that already exist, like Slack, Gmail, etc. So those can be really powerful depending on what you're building. If you are building your own MCP server, I highly recommend using Enrich MCP to do what we were just talking about of how to connect it to your data sources. So there are some pre-built servers. So if you have a very specific use case, like I want to connect to Gmail, just go use the pre-built one. If you have something a little more broad, like you're building your own application or you have your own application you're trying to use with an agent, I recommend using Enrich MCP. Right. Take it away, Marie.
Thank you guys so much for attending the webinar. We had a lot of people today. So after this, I'll send you guys an email with a link to the recording of the webinar. Simba, someone asked if we could send the slides as well.
Yeah, I can send that to you so you can send it over.
Okay, cool. So we can send the slides. Also include links to Enrich MCP. We have it here, but I'll send it to the email as well. Um, and also I'll send links to our Slack community and docs. So you can, if you need to just learn more about um, ML in general and also connect with other people in the community, you can join our Slack community. Um, cool.
Awesome. Well, I don't see any more questions. If you have any more, you can always ask me. I mean, I'm on LinkedIn. I'm Simba at featureform.com. If you do end up using the tool, you can join our Slack community to ask more questions. Yeah, and if you have anything else you want to share, feel free to send them our way. But thank you for making some time this morning or afternoon or evening, and hope this was valuable. Talk soon.